Hey guys, Mr. B here, and this video is going to be going over the measuring volume and temperature lab. So we're going to be looking at the pre-lab questions to begin with, and then we will take a look at the post-lab questions. So to begin with, the pre-lab questions, number one, it says, why is it important to read the volume of water in a graduated cylinder by using the bottom of the meniscus? So one, you might not even know what is the meniscus. So when you put water in a graduated cylinder, okay, a graduated cylinder is basically a big column. The water kind of curves like this, okay, so the edges of the water kind of curl up the graduated cylinder, and then it gets this kind of curve. And the bottom of that curve is what we call the meniscus. So the question really is asking, why is it important that we read the water at the bottom of that curve rather than up wherever the highest part of the water is? And the main reason for that is because the water can creep its way up quite a bit. If we read at the top of it, our volume is going to be a lot higher than it actually is, so we get a less accurate number. Whereas the bottom of the meniscus also isn't exactly, but it's a lot closer to what it would actually be versus if we read it at the top of the curves. So basically the short answer is we get a more accurate number for volume by reading the bottom of the meniscus than by reading the highest part of wherever the water is. All right, number two, it says, why should you leave the thermometer in beaker B when you add ice? So the primary reason you want to do that is it takes less time for the thermometer to adjust to the proper temperature versus if we put the thermometer in, read the temperature, then pull it out, and then we put it in later, we have to wait for the thermometer to adjust to the temperature, and that takes time. And all while we're waiting for this thermometer to adjust to the temperature, the ice is going to be continually melting and also cooling the water down. So that thermometer might just keep on dropping and dropping, and it's a lot easier if it's already in there because it's adjusted, and we can just look at it and read whatever the reading is, and then that's it. Okay, so basically, again, short answer is we don't have to wait for the temperature to adjust, and it's faster to read. We get, again, a more accurate measurement. All right, the last pre-lab question here, number three, it says, if each mark on a thermometer represents 1 degree Celsius, which part of a temperature measurement will be the estimated digit? So basically what this question is saying is, if you have a thermometer and every mark on it is 1 degree Celsius, let's say it's between 1 and 2 degrees Celsius. And you had to make a reading, right? You had to write down what's the temperature, and it's somewhere between 1 and 2. What are you going to write? Well, you might say, oh, it's 1.5, or 1.4, or 1.6. Either way, you know that it's going to be 1 point something, right? If it's between 1 and 2, you definitely know it's 1 point something. And the estimated digit is the number that comes after the decimal, right? 0.4, 0.5, 0.6. That's a guess. Because there's no markings on the thermometer that will tell you if it's 0.4 or 0.5 or 0.6. You're just making a guess. So for the third question, which part of a temperature measurement will be the estimated digit? The last one. Okay, the last number will be an estimated digit because you usually always have to round or estimate at the end just because our tools and our equipment don't give us really precise numbers. There's always that little bit of guessing at the end. So, all right, so we're going to do the lab part of this, and then after that, there'll be some post-lab questions, and then I will help you answer those ones as well. All right, see you there. All right, guys, this is part one of the lab. So we're going to take this beaker, which is 50 milliliters, and we are going to fill it halfway up with water. All right, so we have our beaker halfway with water here. Now we're going to put it in a graduated cylinder and see what the actual volume is. All right, so our water now is in the graduated cylinder. So on your data sheet, I'd like you to make note of where that water line is. Again, the bottom of the meniscus, and just estimate it to 0.1 milliliters. So looking at this right now, it looks like it's maybe between the 33 and 34 milliliter mark. All right, so this is now the second part. We are filling this beaker up to only a quarter full. We're going to put it in a graduated cylinder, and we're going to measure how much the volume is up to 0.1 milliliters. All right, so we've now taken that 1/4 filled beaker, we've put it in a graduated cylinder. So again, on your data table, I'd like you to write down how much volume of water is in here to the closest 0.1 milliliters. So it looks like it might be between about 21 and 22. All right, guys, this is going to be part B of the lab. So right now we have two beakers. We've labeled 1A and 1B, and we're going to put 50 milliliters of water in each one. So here is 50 milliliters of water for beaker A. Let's pour this in. And here is 50 milliliters of water for beaker B. So let's pour this one in as well. So we have both beaker A and B now with 50 milliliters of water in each. We're going to put a thermometer in each one, and we're going to record what the temperature is before we do anything else. All right, so before we start, it looks like the temperature for beaker A is about maybe 19 or 20 degrees Celsius. We'll say maybe 19 or 19.5. Looking at the thermometer for beaker B, it looks at about the same place, so maybe about 19 degrees Celsius or 19, we'll say about 19 degrees Celsius. All right, so now we're going to add an ice cube to beaker B. So I have an ice cube here. We're going to add this in. And after a minute, we're going to check the temperature of beaker B and compare to C. And then after 5 minutes, we are going to check the temperature again, and then we'll look at the volumes. So here we go. Looking at our thermometer for beaker A, after 1 minute, it looks like the temperature is still at about 19 degrees Celsius. All right, so it's been about 1 minute, and we can see that the temperature for beaker B is maybe at about 13 degrees Celsius. So you're going to record about 13 degrees Celsius after 1 minute of ice. So let's put it back in, and we're going to wait for 5 minutes to pass. All right, so it has been 5 minutes. Let's check the temperature of beaker B here. So after 5 minutes, it looks like the temperature is around 10 degrees Celsius. Looks about 10 degrees. We will check also for beaker A, though I assume it's at 19 because we didn't do anything to it. So let's just check anyway. And maybe it went up to about 20 or so, but not much of a change. So if you want to keep it at 19 or about 20, that should be fine. So now we're going to pour each liquid into a graduated cylinder and see what the volume reads after one of them has been cooled down and the other one has not. Looking at the volume for beaker A, it looks like the liquid is still at about 50 milliliters, which is what it was at before we started this 5-minute timer. So looking at the graduated cylinder of the liquid for beaker B, it looks like our volume went down by about 2 milliliters. That's kind of interesting. So I have the sheet in front of me with the questions, as I'm sure you are looking at yours, maybe online. We're going to answer questions 1 through 4 together. That way, if you have any confusion, hopefully this can help you. All right, so number 1, it says, what is the largest volume of liquid that the graduated cylinder is able to measure? So in this lab, we used a 50 milliliter graduated cylinder, which means the largest amount of volume that it can measure is 50 milliliters. But granted, there are other graduated cylinders that can measure more. It can measure up to 100 or 250 or even 1,000 milliliters. But again, this one is 50. The second part of the question says, what is the smallest volume that the graduated cylinder is able to measure? So you might think it's 0. But, well, actually, you know what? We'll say it's 0. But we could also interpret this question as, what's the smallest amount of liquid, right, in the graduated cylinder that we could use to measure? So On the graduated cylinder, it had markings every 1 milliliters. So the smallest amount of volume you could measure is 0.1 milliliters, or a tenth of a milliliter. Because let's say that it's between like 5 milliliters and 6 milliliters, you could estimate it to be like 5.5. And that's the best you could do. Okay? You couldn't say like 5.55 because there's no markings in between there. So either way, how you want to interpret that, I would say the smallest amount of volume you could measure is a tenth of a milliliter, 0.1. But technically, 0 milliliters is the smallest amount you could put in there and measure, or 1 milliliter. All right. Number 2, it says, describe how the temperature of the water in beakers A and B changed during the investigation. Well, we put an ice cube in beaker B, so the temperature dropped by about 9 degrees during a 5-minute period, whereas the temperature in beaker A didn't change at all because we didn't do anything to it. So we could say that, again, the temperature in beaker B dropped 9 degrees during our experiment, and the temperature in beaker A didn't change at all. All right, number 3, how did the volume of water in beakers A and B change during the investigation? So the volume for beaker A didn't change at all during our experiment. It stayed at 50 milliliters the whole time. However, the volume in beaker B went down by about 2 milliliters during our experiment. Now the question is there's a follow-up to that that says, what do you think caused this change? So we did, of course, put ice in beaker B, which reduced the temperature. And when water gets cold, it shrinks. Okay, now this is kind of a weird concept, but when water gets cold, it shrinks, and when water gets hot, it expands. So when you lower the temperature of beaker B, I think that the volume goes down because the water molecules kind of shrink together, which then causes the overall volume of the water to get smaller. Okay, so that's what we could put down is, what do you think caused this change? The lower temperature caused the water to shrink, or the water molecules get closer together, which overall caused the liquid to reduce its volume. All right, and then number 4, would you use a 100 milliliter graduated cylinder, a 25 milliliter graduated cylinder, or 10 milliliter graduated cylinder to measure 8 milliliters of a liquid? And it says, explain your answer. So all of these, to be honest, would probably work just fine, but the best one would probably be a 10 milliliter graduated cylinder, because of the fact that 10 milliliters is about this big, and each little marking on there is going to give you a lot closer measurement to 8 milliliters, whereas if you put it in a 100 milliliter graduated cylinder, which is much bigger, I think you maybe only have markings every 1 milliliter, whereas on a 10 it might be every like half a milliliter. So it would be best to use the graduated cylinder that is closest to the amount of volume that you're trying to measure. Okay, so our answer for number 4 could basically say we would use the 10 milliliter graduated cylinder because it is the closest volume to 8 milliliters, which is what we're trying to measure, and that will give us the best measurement with the closest numbers, or I guess using vocabulary, the most precise numbers. So, okay, hopefully that helped you, and I know it wasn't a super long, set of questions, but hopefully if you had any confusion, that was able to help you. But again, as always, if you have more questions or you need more help, reach out to me and I can help you then. All right, guys, I'm Mr. B. Thanks for doing this lab, and I will see you in the next one. Bye.